Good morning, everyone. Nice to see you. I hope you're doing well. I want to make a connection with some of the things we've been talking about with thermal radiation and how to stay warm, when it's cold out. If you happen to have access to some aluminum foil, maybe you're sitting at home, I'm going to do a little experiment that you can do at home at the end of this segment. So we know that if I have any kind of a warm object, it's going to be emitting thermal radiation, electromagnetic radiation. For something that's at a temperature like me, human body temperature, that'll be emitting around, say, 10 microns. And the amount of power that's emitted goes like the fourth power of the temperature, but it's also proportional to this property of the thing that's emitting called the emissivity. And that goes anywhere from 0 to 1. And we previously saw this rather amazing fact that for human skin, it doesn't matter what the skin tone is in the visible, but in the infrared where we emit, the emissivity is essentially perfect. So it's very, very close to 1. So we're very good emitters of thermal radiation. And we can ask, well, why is that? What would be the reason for that? And that's going to have to do with thermal management or heat management. So it turns out that humans need to be able to dissipate somewhere between 100 and 500 watts of heat, basically all the time. So it depends how big you are, if you're a man or a woman, and what kind of activity you're dealing with. The more active you are at a given time, the more heat you're going to need to dissipate. But roughly speaking, 100 or 200 watts is sort of common. And just to put that in context, if you eat 2,000 calories a day, that corresponds to something like 100 watts needing to be emitted all day. Okay, so one other thing just to remind you of, if I have an object and it's in a room at the same temperature, the amount of thermal radiation that object emits has to equal the amount that it absorbs. If that weren't the case, then the object could either spontaneously heat up or cool down, but that's against the second law of thermodynamics. But we can ask, what if the temperatures aren't the same? So for example, if I'm in a room that's at 70 degrees Fahrenheit and I'm at 98.6 degrees Fahrenheit, I'm going to be emitting thermal radiation. How much radiation will I emit? Well, this is the complete formula for calculating how much power is emitted. There's this constant, there's this emissivity that we said is really close to 1. There's the temperature of my body in Kelvin to the fourth power, and then whatever the surface area is. So if I just calculate that, I'll find that I'm roughly emitting something like 920 watts of power, like all the time. And you might think, well, that sounds like it's an awful lot. You're only supposed to be getting rid of 100 to 200, and yet that's 900. So it seems like you're emitting way too much. But remember, I'm also absorbing from the room. So because the room is at 70 degrees Fahrenheit or 294 Kelvin, I'm going to be absorbing thermal radiation from the room. And the calculation is exactly the same. The only difference is I replace the 310 Kelvin with 294 Kelvin. And that means I'll be absorbing about 750 watts. So the net power that I emit is just the 920 that I'm emitting minus the 750 I'm absorbing, and that corresponds to about 170 watts. And that's kind of right in the ballpark of the amount that I said that I needed to be able to get rid of. So thermal radiation is a main way that we achieve cooling to get rid of this extra power. Let's ask what happens if I'm in an environment that's a lot colder though. So let's say it's 0 degrees Fahrenheit or 255 Kelvin. In that case, the amount of power that I'm absorbing is a lot less. It's only something like 420 watts. And that means that the net power that I'm emitting is now something like 500 watts. And again, that's a lot more than I would normally need to do if I'm just standing still. I only need to get rid of maybe 150 watts or something like that. So that's going to be a problem because I'm emitting way too much. I'm going to get really, really cold then. So the question is, what can I do to help prevent that? Well, you could imagine if I could surround myself in some sort of a material that would be able to reflect back to me all that infrared radiation that I'm giving off, all that 920 watts. Well, then I could then absorb that again. And then the net power that I'd be emitting would be, something close to 0. And so instead of emitting 500 watts, I'm basically emitting nothing. I'm going to be able to stay a lot warmer that way. And that's the basic principle behind, for example, the space blanket that was developed by NASA and that's used for hypothermia victims. So it's basically a metallic coated sheet of plastic that's able to reflect, almost all of the heat that's radiated by that person. And that's the same sort of principle that's used in a jacket. So for example, here's my winter coat, and the inner lining of it has the same sort of reflective dots on it. Now, it turns out they're only covering maybe 33% of the surface area, so they're not going to reflect everything back, but they're still going to reflect back quite a bit, and that's going to definitely help to be able to keep me warmer. Okay, so we can now do this at-home demo. If you happen to have a piece of aluminum foil, you can just do this at home. I'm just going to hold this close to my face, maybe a centimeter away. I'm not going to be touching the skin at all. I'm just going to hold it close and just wait for a couple seconds. And I can definitely feel that the skin on my face is feeling warmer. And that's because instead of just leaking off that infrared radiation, it's being reflected back to my skin by this piece of aluminum and helping to warm it up. So of course you don't want to go around wearing aluminum foil in the winter, but that's the basic principle by how a lot of these like jacket linings work. Okay, so I hope you can stay warm by that or any other mechanism, and we'll see you guys later. Maybe next week, hopefully we'll talk about how our skin helps us with ultraviolet radiation, because that's another really interesting story. Okay, have a great week. Bye-bye.